we are going to look at trig ratios, and we're going to do an example using trig ratios. So let's first start with the concept of a trig ratio. So with trig, we look at triangles and how these triangles relate to each other. What we actually look at is a special right triangle. The special right triangles are a 45, 45, 90 triangle, a 30, 60, 90 triangle, or a 60, 30, 90 triangle. And we look to see how these relate to each other, and as we go through this, we're going to introduce what's called a unit circle and how all of this ties together to determine wave functions and things like that. All right, so first of all, we use a common symbol called theta. Theta is used to describe angles in degrees. So the angle with the measure theta. In this case, we have our triangle, our special right triangle. Don't really know what the angle is quite yet, but we have theta. And where theta is, the leg that is touching is the adjacent leg. The leg that it's not touching is the opposite leg. So when I say touching, if you draw this little arc here, if the arc goes through that leg, that's the adjacent leg. If it does not go through that leg, it's the opposite leg. And then the longest leg is the hypotenuse. All right, so there are 6 basic trigonometric functions for the angle theta. The first one is sine. And sine is equal to the opposite leg. I'm going to put O over the hypotenuse. Okay, then, this is theta. Then you have cosine theta. That's equal to the adjacent leg over the hypotenuse. You have tangent, T-A-N. So tangent of theta is equal to the opposite over the adjacent, or this is equal to sine of theta over cosine of theta. All right, then we have what's called the cosecant, CSC theta. This is basically the reciprocal of sine theta, which is going to be hypotenuse over opposite. We have this secant of theta, which is going to be the reciprocal of cosine, which is equal to the hypotenuse over the adjacent. And then we have the cotangent. I start writing CO. The cotangent of theta, which is going to be 1 over tangent theta, or adjacent over opposite, or cosine theta over sine theta. All right, so there are 6 basic trigonometric functions right there. There is the basic right triangle with its adjacent, and here's written out as well. Here's the basic right triangle, and then the different triangles that we are going to be primarily looking at with our examples and our work. All right, so let me hide this guy and delete this, and we're going to delete this. Let's go into our first example. So we want to write a trigonometric ratio given a triangle. And again, I usually say there's just 3 certain triangles, but as long as we know 3 sides, we will be able to find the cosine, sine, tangent, cosecant, and secant and cotangent. And then let's make that there. All right, I'm going to get my handy dandy eraser because I've obviously gone too far with some of these lines. Just kind of erase it. There we go. So we have a triangle. And our triangle, the hypotenuse is 29. This is my theta here. All right, my adjacent, because this is the one that the theta arc goes through, is 20. And then my opposite is 21. All right, so we want to know, given the right triangle here, write the 6 trigonometric ratios for the given angle with the measure theta. We don't know theta yet. You guys have not theoretically learned how to find theta yet. We're just going to write what the answers or what the sine of theta is going to be, cosine of theta is going to be, and so on and so forth. So sine of theta is going to equal the opposite over the hypotenuse. And that's an O, not a 0, but OP. All right. So opposite is the one that this arc is not touching. That's 21 over my hypotenuse, which is 29. Cosine, we're done with that one. Cosine of theta equals the adjacent over the hypotenuse, which is going to be 20 over 29. Not too bad. Tangent of theta is going to be the opposite over the adjacent, which is going to be 21 over 20. Okay. Now the cosecant, CSC, of theta is going to equal 1 over, or the reciprocal of the sine of theta, so 29 over 21. The secant of theta is going to be the reciprocal of cosine, which is 29 over 20. And the cotangent of theta is going to be the reciprocal of tangent, which is 20 over 21. Right? Not too bad. And so there are these 6 functions using a right triangle. This is not a special right triangle. This is just a regular right triangle with a hypotenuse of 29 and legs at 20 and 21. All right, guys, so this is the end of this example, and if you have any questions or comments, always feel free to get a hold of me, and I will catch you in the next video.